Hello, my name is Kevin and this is Calc 101. I will help you with the test problems. So you have number one. I may branch out a couple of times to further explain things to make sure you actually understand what's going on. You have f of x equals x cubed e to the x. So you're going to want to do the product rule. I hope you know what the product rule is, but if you don't, you take the derivative of the first term multiplied by the same thing, the second part right there, and then so it'd be 3x cubed times the same thing. You don't take the derivative of that, e to the x, and then you have a plus sign, and now you take the derivative of e to the x, which is e to the x, and then times that thing without taking the derivative of it. And that is your derivative. Pretty simple. I don't believe you could simplify that any further, but moving on. Oh, and just a side note. Generally speaking, e to the x is always e to the x when you're taking the derivative of it. But if you had something, say, to the 2x, what you would do is take the derivative of what's, the exponent, which would just be 2, and multiply to the outside, and then leave the exponent the same. So it'd be 2e to the 2x. That was just kind of like an FYI kind of thing. Now, moving on, you have 8xy plus 7lny equals 32, and you want to find the slope at 0.41. Now, I don't really want to go all the way through it, so I will probably stop when I feel like you can finish it. So first, you want to take the derivative of all of this. You have, oh wait, let me draw some parentheses, make it a little easier to see. So you do the product rule again for this part, and so you take the derivative of that, you get 8 times y, because you're just multiplying it by, the same thing, the second part of the same thing, plus, now you take the derivative of y, and when you're doing implicit differentiation, you do dy dx, and then you just multiply that by, the first term again, 8x, and then you have plus 7lny. Now, it's not as tricky as it looks. The derivative of ln to the x is always going to be 1 over x. Now, with that in mind, adding a 7 there would just make the numerator multiplied by 7. So it'd be 7 over y. If the 7 weren't there, it'd be 1 over y. And then you take the derivative of 32, and since that's a constant, it's just 0. And so where do you go from here? You solve for dy dx. Oh, my bad. This should be dy dx, because you're again taking the derivative of what's inside this ln, this natural log, multiplying it by the entire thing. So that's why you have the dy dx on the outside. And then you equal it to 0. And so you want to subtract the 8y over. And so you'd have dy dx 8x plus 7 over y dy dx equals negative 8y. And let me erase some of this just so I could have more space to write this recording software is kind of wonky. I downloaded it probably. Oh fuck! Didn't mean to erase that. So 4, 1. Okay, so I'm gonna work up now, just so you could see it a little better. Okay, so now you want to pull out the dy dx. And then you have 8x plus 7y. Yeah? And then equal that to negative 8y. And now you divide it over. So after you do that, let me just rewrite it down here. After that, you just do dy dx equals negative 8y, and then 8x plus 7 over y. Now you plug in your 4, 1 into your thingy mabobber, and then you get negative 8, 1 over 8, 4 plus 7 over 1. So then that becomes negative 8 over 32 plus 7, or negative 8 over 39. Now, I do want you to double check this with James, because sometimes my math is a little wonky, but I have faith. That makes sense to me. Just a heads up, I did work through some of these already, so I am familiar with it, but I only got to like number 4, so I may start like hesitating a bit more once I get to 5 through 7. Okay, so now we're on number 3, which is just f of x equals e to the x over 1 plus 2x squared. So with this, you do the quotient rule, and I don't know if your teacher taught you this, but here's a little thing I do to remember the quotient rule. So you have low d high minus high d low, draw the line, and square what's below. So say it with me. Say it out loud if you want. Low d high minus high d low, draw the line, and square below. It's a little neat trick, and you'll see it coming in handy in just a second. Okay, so first you do low, which is just that. 1 plus 2x squared minus, that low, then it's d high. So you take the derivative. When I say d high and d low, it means take the derivative of, if that didn't like click. So now it's d high, which is e to the x, because e to the x is always e to the x, minus high d, which is still e to the x. Oh, did I do that wrong? It goes low d high minus high d. Oh wait, no, yeah, I'm on the right track. I'm on the right track, but it's just I explained this portion wrong. You're just doing. Oh wait, no, I didn't. Fuck, I messed up, didn't I? Can you just ignore the past 30 seconds? So you have, yes, the low part right here, and then the d high, which is the derivative of the top, then minus high, which is just that, and then d low, which is taking the derivative of this, which would be 4x, because the 1 disappears, and then you do 2x squared, which just becomes 4x, and then draw the line and square what's below. And that should be your answer. I wouldn't expect your teacher to expect you to simplify that, but yeah. My bad with the screwing up on the explaining portion. Words sometimes get messed up. Okay, so now we are on to number 4. Now, number 4 brought me a lot of headache in trying to figure out. It's what I spent a significant amount of time trying to figure out. And you said like 5 seconds ago that the 8 is definitely on the outside. And I want to do both this and this. In case you are incorrect and it's actually on the inside. Wait, did I say you said it was on the inside? I meant you said it was on the outside. But I'll do both just in case. It'll be good practice for me, I guess. So we'll start with this one. It's very tricky, honestly. So first thing you're going to do is do your u substitution. So your u will equal ln x. Your du will be 1 over x because the derivative of ln x is just 1 over x. And so you have your 1 over x right here, so you could just stick that straight in. And so this would become e to the 6 e 1 over u, and then that 8 is still there, so it'd be u to the 8. Oh, that is quite ugly. And this looks okay right now, but it's not really. So then you have technically u to the negative 8, and then you'd want to take the antiderivative of that, and so you'd add 1 to your exponent and then divide by your new exponent. So you do plus 1, which would be negative 7, then you divide by your new exponent, which is negative 7. So you end up with negative 1/7 u to the negative 7. And you plug your u back in there, and you get negative 1/7 ln x to the negative 7. Sorry, which is also the same thing as 1 over 7 ln x to the 7. And now is what I find to be the hard part. Oh, nope, not that. E to the 6 and e. You have to plug in your e to the 6 in there, into that x right here, and then subtracted by your e plugged in back there. So it'd be like negative 1/7 ln e to the 6 7 minus it would actually be plus because you're minusing a minus, plus 1 over 7 ln e to the 7. And that is your final answer, because I don't think you could simplify that anymore. Maybe you could bring that 7 into the 6, but I doubt it. But that would be your final answer in terms of this tricky boy. And now let me go over the second portion that it could possibly be with the exponent on the inside. Okay, let me unlock my phone, because that's what it is on. So let's say it was actually e to the 6 e 1 over x ln to the x 8 dx. Now this makes things a lot easier, because now you could apply the power rule, which means you could bring that 8 and put it right there. So then you have e to the 6, and then 1 over 8x ln x. Your u would be ln x, sure. Then your du would be 1 over x. You could pull this 1/8 out, so it'd be 1/8 e to the e6 blah 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 1 over, since the x is right here, you could just, pull it out in place, so it ended up being 1 over u, and the ln x cancels out, that's why it disappears. Now, if you don't understand why I pulled the 1/8 out, it's because it's a constant. It's just a number. You could just pull it out. It doesn't have anything to do with, the variables inside. Because it'd technically be times 1/8. So you could just pull it out. So now you're at this bottom portion right here, this 1 over u. So this would become 1/8, and then ln, you carry that back after you take the derivative, which would just be ln of u, but then you plug in your u, and so it'd be the ln of the ln of x from e to the 6 and e. Now this looks confusing, yes, but it's not that much. It isn't that confusing if you know your natural log rules. So when you plug in this e to the 6 in there, you end up with ln to the ln of e to the 6. Well, the 6, anything ln e always cancels, and then you're left with just the exponent. So it'd be ln to the 6. Do you see what I did there? Spiffy, isn't it? And so you'd have ln 6 after you plugged in e to the 6. And then you'd have ln of e, which is let me teach you this rule I know. Okay. So it goes e o o no. Okay, so it goes he, hi, ho, l-o, no. You're just adding h's in front, which kind of look like ln's if you think about it. So you have he, hi, ho, l-o, no, which means the ln of e is 1, the ln of 1 is 0, and the ln of 0, no way Jose. Okay, so you stick the ln of e in, and you have 0 popping out, and now you have the ln of 0? No, it's the ln of, frack, it's ln 1. Then it becomes 0. And then you just have 1/8 times this is as far as I got, so just give me a sec. We'll work through this. What did I say it was? Oh yeah, ln of 6. That's your final answer. Because after you plugged in this e right here, it became 0. So it would be 1/8 times 0, which would just be 0. Because this would be ln of 1, it'd be the ln of the ln of 1. ln of 1 is 0, so then, no, fuck. Yeah, fuck. No, you do the ln of e, and then, forget what I just said again. Sorry, I'm kind of new at this. If I make you videos in the future, I swear they'll be more rehearsed, but it's just getting kind of late, so I just want to do it all in one take. This becomes the ln of 1 after you plug in, after you have the e in, and then it becomes 0. So this is it, which is a lot easier than the last one, in my opinion. Now, ideally, I will cut out a lot of the parts if I could find out how to properly video edit. But we'll see. We will see. Okay, let me pull up the next one. So now you are on number 5. And number 5 is integral. of course. But you're not given any limits, so you're just taking the antiderivative. X over 2x squared plus 3. Yeah, this is as far as I got. So I haven't done this yet. So as always, bear with me. I say the first thing you do is do some u substitution. You have negative 2x squared plus 3. Then your du is negative 4x. The 3 disappears. Dx. And so you have the x there, and then since you don't have a negative 4, you just create a negative 4 by dividing by 4, which would make there become a negative 1/4 on the outside. So then you have 1 over u, then you have negative 1/4 ln u. Keep in mind that when you're taking the derivative of 1 over u, or 1 over x, or whatever, it has absolute value signs. So then you sub in your u again, and you get your final answer of 1/4 ln negative 2x squared plus 3. Beautiful job, Kev. Beautiful. Okay, so moving on. Oh shoot, there's a lot of random dots on the board. Okay, so now we are on number 6, which is, what is this? You say the 6 is an integral as well. So, e to the negative 4x to the negative 3. Then you have x to the negative 4. Give me a sec as I piece together what to do. Okay, I see what to do. You're u substituting. Your u should be 4x, negative 4x to the negative 3. Your du will become positive 12x to the negative 4, because you're subtracting 1 from that exponent. And so you have that x to the negative 4 right there. But then you don't have the 12, so you divide a 12 over, which would make there be a 1/12. So you have 1/12 e to the u, because that's, what we used as your u. And then the x to the negative 4 disappeared because it's right here, so just be e to the u, which is, as I stressed before, just e to the u. Oh, frick. Okay, on number 5, I forgot to mention this. Add a plus c to the end of that antiderivative. I forgot what it was. I don't want to pull it back up. But it's plus c. It's plus c. Whenever you do just like a straight up antiderivative, you add a plus c. I'm sure you know that. That's Calc 101. That's Calc 100. Okay. So it'd be 1/12 e, and then you plug back in your u right here. That's supposed to be a circle. Didn't come out so nicely. 4x to the negative 3, and then plus c. It's your final answer. Make sure you add a plus c to that last one. Please. Please. Okay. Okay, and now we're on to fucking number 7. So you say number 7 is find the area of the graph in the region bounded by the y formula. Area of the graph in the region. So this is just saying take the integral. of 1 over x. But you don't have limits, so that's what kind of bothers me. Find the area of the graph in the region bounded by that y formula. Yeah. Okay, so you may be given limits on the test, but I'm not sure. You should have been if they asked you to find a legitimate area. So you just take the integral. And so this would become ln of x. And then whatever your limits are, stick it in, subtract it, and then let's actually make limits in case there are limits. I'm not sure, Nora. This one's weird, but when you're taking the area under a curve, it means take the integral. So, I mean, you're definitely using an integral, but I would assume that you'd find the antiderivative, or if you had limits, plug in the limits. So, yeah, you have ln x, and then let's say your limits a and b. You do ln of a minus ln of b. That is your area under a curve, if you're given limits. If not, and it's just asking for an antiderivative at LL plus c. And that is all I have. Love you. Okay, that was kind of gay.